This is linear programming on the calculator. And if you're wondering why you see all this, I just want to relate this to the other video that I did, if you saw it by chance, which was this linear programming problem. But this time I'm going to do it on the calculator. And I think you'll find it to be easier once you learn the routine. I'm going to get rid of that. And I'm going to get rid of these lines, because I don't need those. I'll bring this back down, and I'm going to get rid of the graph. I'll be using the TI-83. It's going to work the same, basically. Might look slightly different in some aspects than an 85, but for all intents and purposes, it will be the same. Process is going to be similar in some ways and vastly different in others. First of all, I'm going to need to first solve my equations for y equals so that I can put them in the calculator. And I did this before on the first equation. So I've got 3x plus y equals 7. Now I'm leaving it as equals in both cases because that's what I'm going to put into my calculator. I'm going to subtract the 3x, and so then I get y equals 7 minus 3x. And now I'm going to do the second equation. The second equation is x plus 2y equals 9, and so I'm going to subtract x and get 2y equals 9 minus x, and then I'm going to divide by 2, and I'm going to get y equals parentheses 9 minus x divided by 2. And the reason I do that, even though I'm certain I could do that division easily by myself, I'm just going to let the calculator do it. I'm going to avoid the mistakes. My philosophy, and I think yours should be, if I'm going to use the calculator, I want it to do things like calculating for me. Some things it won't do. It won't change these equations for me, but it'll do this division for me right here. So what I'm going to put into my y equals are the two equations that I just got. So I'll highlight those. Right? I'm going to put this equation into y1 or y2, doesn't matter which, and I'm going to put this equation into y1 or y2. Okay, so let's do that now. First equation, really doesn't matter which. I'll go ahead and put 7 minus 3x. And the second equation is, open parentheses, 9 minus x, close, divide by 2. Okay, and now I'm going to move my calculator down. I'm done with that. Make it just slightly larger. Okay, so I want it to shade. Okay, and so the first equation was up here, and y was less than. If you look, I subtracted 3x, so its y is less than 7 minus 3x, and so I'm going to shade below that line. So I go, if you look at the cursor, I move it all the way to the left. You can see what's flashing there. That's the type of line that's graphed by the calculator. So right now it's just a regular line, and we hit enter. That would be a very thick line if I wanted to, and now that's shading above my line, and that's shading below. So I want that. Okay, so if I go ahead and hit graph, I see that. What you will probably see is this. And the difference is that I changed my window. Okay, and the reason I did that is I have these two constraints. Okay, so you saw it before. I'm going to take you back to that. How do I set my window? The first constraint is x is greater than 0. I'm going to go to my window and look here, and I see I've got an x minimum of -10. My x minimum I'm just going to make 0. The problem is that the calculator won't graph a vertical line as a function. I can draw a vertical line, but it won't plot one as a function, and so I can't do an intersection with it. I can't really work with it very much. My x maximum, well, I'm not sure what I want my x maximum to be. I'm going to look at my equation and say, well, you know, I can try and guess some things. I've got a slope of -3 in the first one and a y-intercept of 7, so it's going down pretty quickly. My x max probably doesn't need to be very big, you know, but sometimes I just guess at 20 and say, okay, let's just make it 20. If it doesn't work, I'll just come back and change it. No big deal. Same thing for y. Y minimum is y is 0 because y is greater than or equal to 0. So no values for y less than 0 are a part of my feasible region. I don't need to see them on the graph. Okay? In fact, I don't want to see them on the graph. Okay? Y maximum, well, I know I have a y-intercept of 7 and it's going down, and in the second equation I have a y-intercept of 4.5 and it's going down. 10 probably works. Okay? 10 probably works. So I'll just go ahead and graph it and see. Yeah, that's pretty steep there. There's the other one. You know, maybe I change it. Maybe I make my x maximum 10 instead of 20 and graph it. Again, you can change this however you like. Okay? As long as I can see everything, and I can. Okay, so I go back to y equals, and now we'll shade the second equation. That was also less than, right? I didn't divide or multiply by -1. Y is on the left. 2y is less than. You can see in the inequality. So I can see I'm going to be shading below also. Okay, if I accidentally hit an extra one, no fear. Just keep tapping on enter till you get back to it and just go around, loop around and come back. Okay, now it's going to regraph the first one, and then here's my second one. Okay, so you can see it shaded one of them with vertical lines and one of them with horizontal lines, and so my feasible region is the area that is shaded by both. I'm going to take a picture of that and put it up on the screen for a second. So this is what you see on the window of on the screen of your calculator. Okay, so this is my feasible region is the area that is cross-hatched. It's got both vertical and horizontal lines. Okay, so the vertices of that, which is where my maximum or minimum will always be, are at the origin, this point, and that point. Okay, this point I know automatically. I know it's 0, 0, and I know without doing really any work that if I multiply 2 times 0 plus 0, I'm going to get 0. That's not going to be my maximum function. But there are times when you may need that value. Okay, so don't forget about it. Don't just assume it doesn't count. All right, so then I have three other ones. I have an x-intercept right here. I have a y-intercept right there, and I have a point of intersection right there. Each of those will be calculated in a different way on the calculator, but I will always be going to the same place to find the method to calculate. Okay, so let's take a look at that. Okay, so now I'm going to find the 4 points. Again, we already did this one, and if I substitute that in, I know that's 0. So I'm not going to worry about that too much. Okay, I'm going to pretty much be on the calculator now, so I don't really need all of this. So let's just get rid of it. Okay, on the calculator, first point I'm going to find is the y-intercept. That's this point here, x-intercept, excuse me. That's this point here. Okay, really doesn't matter what order I go in. So the most common thing I'm going to do here is I'm going to go to second and hit the trace button. And second trace is calculate. Okay, so that looks like second trace. I'm at calculate. I'm trying to find the x-intercept is what I said. So if I want the x-intercept is when y equals 0. So on the x-axis, y equals 0. Remember, it's that line, y equals 0. Okay? So when y equals 0, that's number 2 on the calculator. I can just type a 2. I'm finding a 0. Okay? So then I'm going to pick 0. It's asking for left bound. Remember, this means I'm finding a value for x. You can see it right here. That's to the left of that intercept, which is right about here. 0 is left of that intercept. I'm just going to type in a 0 and hit enter. And now it's going to ask me a right bound. Well, as I recall, I set my maximum at 10. That's to the right of this point of intersection. I'm not worried about up or down at all. I'm just left or right. Okay, so if I just put in 10, there we go. Okay, guess. Looks like 2.3 repeating, or 2 2/3. Excuse me, 2 1/3. So 2 1/3, or 2.3 repeating. Okay, if you've done this by hand, you might recall that 7/3 was what we got. Well, that's 2 1/3. The next point I'm going to find is my y-intercept. My y-intercept is when x equals 0. So I'm going to go same thing. Second, trace, except this time I'm going to pick value. And then I'm going to enter a 0. So I'm picking value, which it's already selected. I'm going to let x equals 0 and hit enter. Now the trick here is that it's going to find the y-intercept for both functions. You can see the cursor way up here. If you're looking at the calculator, way up there, the cursor's blinking. That's not the one I want. I want this one down here. So I can change the function it's choosing. It's displaying the function up here. It says y1. I actually want y2. If I hit the down arrow, it goes to the other one. And I can see 0, 4.5. Okay? I want to find the last one. Second, calculate. That's the intersection of two lines. Pretty obvious right there. Intersect. That's 5. I only have 2 functions in. First curve means, do you want to use the first line, the line in y1? It's asking me, here's the one it's saying. Is that the one you want to use? Yes. The second curve, you want to use the other one that's in your y equals and y2? Yes. Guess. Don't worry about the guess. Intersection is at 1, 4. Okay? So that was second, trace, and choose intersect. And then left bound, right bound. Okay? Now, what I told you before was that we'd be able to actually do this calculation. So I wanted to get through and find those points first, but now I'm going to redo it so you get to see me do it again, except this time I'm going to substitute those values into that function and have the calculator compute them automatically. Now the numbers are pretty easy, so when you're doing this one, you might not need to do this, but in a more complicated one, it might be helpful. And if you have to do lots of them, it might be helpful also. Okay, so I'm just going to get out of there for a second, and I'm going to clean up. The function I want to maximize is 2x plus y. That means take 2 times the x coordinate and add it to the y coordinate. So 2 times 0 plus 0 is 0. We did that one already. Okay? What I want to do is show you how the calculator can do it for you. Okay? So I'm going to go back to my graph, and if you recall this number here, the 2.3, that was the x-intercept. That was this point here. So I'm going to review how to do that. So that was second, trace, calculating. I was calculating the 0, right? And I want to make sure I've got the right curve, okay? This is the one I'm calculating. Negative 3x is coming down. If you're not sure, just move arrow to the right and see that it's on the correct one. That's the curve. See the cursor moving there? That's the one I want. So now left bound, I'm going to pick 0. I know it's to the left. It doesn't have to be close. It just has to be to the left. Right bound, I picked 10. And then jump right over guess. Now, the calculator has stored in its memory 2.3 repeating for x and 0 for y. So I'm going to quit, and now I'm going to say, please tell me what 2 times x plus y is. How do I get to y? Alpha 1. You can see right there on your calculator, to the right above the button is the letter y, and it's the same color as your alpha key. Your alpha key might be a different color than mine, but they match, and that tells you the way to get that letter is by hitting that button and that button. Okay? And now I hit enter, and there I go. It multiplied it for me. Okay, so now I know this is 4.6 repeating, or 4.67. I'm looking for a maximum. That's out. Now I'm going to do the same thing with the y-intercept. Second, calculate, go a little quicker here. Value, I'm going to calculate 0. I'm going to hit enter. I'm just going to make sure I've got the right one, because it defaults automatically to y1, but I don't want y1, I want y2. So I just hit the down arrow to select the correct graph. Just look and see. Make sure you're at the right place. Okay? And 4.5 is my number. Okay? So now I'm going to quit to get out of there. Now the calculator remembers this function or this expression that you just had in, and you can bring it back by hitting second and enter. It brings back the same one. Hit enter to execute that, and 4.5. Well, of course, right? Because I was just adding y, I didn't multiply it at all. So this one is 4.5, which means since 4.5 is less than 4.6, it's out, right? 4.5 is not the maximum. Now I'm going to do the last thing again. Second, calculate intersection is 5 here. I'm just going to hit a 5. I need both first curve, second curve, guess. There it is, 1, 4. Quit to get out, second entry, enter, 6. There's your winner. That's out. So the maximum value is 6, and it was at the point 1, 4. So you might be asked one or the other, or both. And there you go.